Hey guys, Mr. Mackey here. Now yesterday I introduced you to the opposite of differentiation, where we change from a differentiated equation back to the original with the y. And that is called integration. And the challenge I set you yesterday was to integrate this equation. It looks complicated, but I can assure you it isn't. So let's do it. So what we do is we integrate by adding 1 to our indices. So I'm going to write x to the power of 6. Then we divide this coefficient by the new integral. So we divide our x to the power of 6 by 6. Now let's do it to this one. X to the power of 4, we do the exact same thing. So we have our x and we do it to the power of 1 more. So it's x to the power of 5. Then we divide it. So it becomes x to the power of 5 over 5. Next one, x to the power of 3. When you integrate it, it becomes x to the power of 4 all over 4. X to the power of 2. When you integrate it, it becomes x to the power of 3 all over, I'm sure you can figure out now, 3. Now we have x, which is the same as x to the power of 1. So when we integrate it, it becomes x to the power of 2 all over, you guessed it, 2. Now the final one, 1, that's the same as 1 times x to the power of 0. So when you actually do the integration, it becomes x to the power of 1. And we divide it by 1, which means we can just leave it like that, or we can just get rid of that 1 in general, so it just becomes x. If you've got that, I will give you 1 of the 2 marks available. There's one thing you forgot to do. What do we add on at the end? The plus c, and that will get you the other mark. You always need to remember that plus c. Now, for the final last week of algebra, for the final day, we're going to be doing a bit more integration and a bit more into the topic. Let's see what I mean. Now, I want to fully integrate this equation. And when I do that, I also have the y-coordinate. So I can actually find out what c is. But we'll worry about that in a minute. What we need to do first is we actually need to integrate it. So, let's write y here. Now we have 2x, which is the same as x to the power of 1, so we write x to the power of 2, and obviously we have our coefficient at the beginning, which is 2, and we divide that by 2. We'll tidy this all up in a minute, because that's the coefficient, and we're dividing it by the new integral. Now for this one, we have our plus, and we have 3, but we're adding an x on because that's the same as x to the power of 0, so we do x to the power of 1, and we're dividing it all by 1. Now when we tidy this equation up, it becomes 2x squared, which I'll just write here, plus 3x, but we also need to add our plus c. Now, what we know, thanks to this little bit in the corner, is that all of that will equal 10. And we know what our x values are. So what we do is we have our 2 and we do square the x value we have. So we do 2 brackets 1 squared plus 3 brackets 1 plus c gets you 10. 2 times 1 squared is just 2. 3 times 1 is 3. And we have our plus c equals 10. That becomes 5. So I'll just move it all a bit up here. 5 plus c gets you 10. And all you have to do is then balance the equation out, and you will work out that c equals 5. Now that we know what that is, we can replace the c in our integrated equation with the number we just worked out, which is 5. So the actual fully integrated equation is when we work out what c is and can replace it with an actual number. So the actually integrated equation is 2x squared plus 3x plus 5. Now let's do one more before our challenge today. So let's integrate this equation first. So we have our coefficient, so we have our x, which we're turning into x to the power 3. And then we divide our coefficient 9 by our new integral. So it's 9 divided by 3. That gets us 3. We now have the 4x. So what we do is we turn that into x to the power of 2. And we divide that 4 by the new integral. So 4 divided by 2, that gets you 2. Then we have our 5, so we put the plus and we turn that 5 into, well, we have the x because it's adding a new integral. Then we divide the coefficient 5 by the integral, which is 1, so it just becomes 5x. And then we have our new c. Now, let's do the substitutions. So we have our 3, and we know that the x value is -2, so we do 3 -2 cubed. Plus, let me just find my pen, plus 2 times -2 squared plus 5 times -2, all plus c, will get us our y coordinate, which is 25. So now let's tidy this up a bit. -2 to the power of 3 becomes -8. 3 times -8 becomes -24. -2 squared becomes 4. 2 times 4 just becomes +8. 5 times -2 becomes -10. And then we add c to that, and that will get us our 25. So let's tie this up a bit. -24 add 8 becomes -16. Then we take away 10 from that, that becomes -26. So -26, all plus c, will get us 25. So what is c? C will be 51. So now that we know what c is, we can just replace it here. So replace the c with 51, and this is the fully integrated equation. 3x cubed plus 2x squared plus 5x plus 51. Now, let's do the challenge. Now, here is your challenge. I have a differentiated equation here, x squared plus 3x minus 10. Now, both the y coordinate and the gradient are equal to 0, and our x coordinate is positive. With that in mind, what is the fully integrated equation? Pause the video if you want to try it, but in about 3 seconds, I'll be going over it. So, one thing I told you is that the gradient is 0, which means this will also be 0. And because of that, we need to factorise this to find out what x is. So what two numbers, when multiplied together, get you -10, but add together to get +3? They will be x plus 5, x minus 2. And from that, you'll get the solutions -5 and 2. Which one is the right one, though? Well, I told you that our x value is positive. So now we know that from this, our x value is 2. Now, we need to integrate this equation. Now, when you integrate this part, the x squared, that becomes x to the power of 3 all over 3. When you integrate this part, the 3x, that becomes 3x to the power of 2 all over 2. Then when you integrate this part, this becomes -10x, and then don't forget, we add on at the end our plus c. And all of this will equal 0. So now we do some substitution. 2 to the power of 3 all divided by 3, plus 3 to the power 3 times 2 to the power of 2 all divided by 2, minus 10 times 2, and then we plus our c. So, 2 to the power of 3 over 3 becomes 8 over 3. 2 to the power of 2 becomes 4. 3 times 4 is 12, all divided by 2 becomes 6. And then we take away 40. Does anyone know what this becomes? You might need a calculator for this. I'm going to use a calculator just so I make sure I get the exact answer. 8 over 3 plus 6 minus 40 becomes negative 94 over 3. So negative 94 over 3 plus C gets you 0. So what is C? C will be 94 over 3. And that's what we replace in this part of the equation. 94 over 3. And that's the end of Algebra Week. Fantastic. Now, here's some news. Because they're predicting by September, all schools will be reopening. And so by the end of the summer holidays, and so by the time the summer holidays comes, there'll be a summer term and then the schools reopen. And let's face it, we don't do much work during the summer holidays, do we? So I've decided that on the 18th, let me just check my calendar, no, the 19th of July, which will be the Sunday after all the schools shut for the summer, that will be the final episode of Mr. Mackey's Maths. Because I know that by September, every child will be going back to school and going back to the education that they have all been missing. And so I'm not really needed. So if you still want my videos to be going, comment below and comment below topics and I'll do my best to cover them as much as possible. And if you want me to continue after this lockdown has ended, I will. But I may not do as much because obviously when the schools come back, I will be going back to teach as well. So I hope you've enjoyed the video so far. Now, I'm not going to tell you what next week's theme is because I want to surprise you. Let's see if you can guess what it's going to be. Take care. We'll see you tomorrow and let's bring on our brand new theme.